The next example we'll take a look at is a retired machine named Nibbles. Once again, make sure to note the IP address here on your screen. Your IP address for Nibbles may be different than mine. Flipping back over to our pwn box running Parrot OS, we'll do the same thing to start that we did for the prior two examples, which is to run an nmap scan with a -a-pn followed by the IP address of the machine we are attacking. In what may be a familiar pattern by now on Hack the Box, we can see that nmap has returned two open ports on this machine. Port 22, indicating that someone has the ability to SSH to this machine, as well as port 80, which is running some sort of HTTP server, specifically Apache 2.4.18. And you may recall from the prior example, Apache 2.4.18 is probably not the newest release of Apache, so this would be an interesting bit of information for an attacker to write down. Just another puzzle piece for them to keep track of. There's not a whole lot else interesting in the nmap scan results, so let's do the second thing we are now familiar with by now, which is to run a nikto scan, giving it http:// and the IP address of our target machine. Now that our nikto scan has returned, let's review the results. As mentioned, Apache is running some outdated version. Similar to the previous example, even though Apache appears to be outdated and potentially vulnerable, in this specific example, we cannot exploit any of the Apache vulnerabilities to escalate our user privileges. So we'll ignore this result for the time being, but it would be something that an attacker would be very interested in. Also similar to the previous example, we can see that some Apache default files are found, which again would tell an attacker that the website administrator probably isn't keeping as close an eye on their web assets as they could. So we'll keep that puzzle piece in our back pocket to see what else we can find. There's not a whole lot else interesting in this nikto scan results. Obviously, we've got some HTTP headers that are not present, which might indicate vulnerabilities of different flavors. But for the sake of this example, we're not interested in those either. Having said all of that, let's try running a gobuster scan to see if we can brute force our way into any directories that we might not otherwise know about. So again, we'll do gobuster dir-u http://10.10.10.75-k to ignore checking the SSL certificates, and a -w to provide a word list, which we're going to use from user share derby word lists common.txt. And we'll go ahead and let this run. gobuster returned really quickly and unfortunately did not find anything useful for us. We can see it found all of the generic htaccess, htpassword, server status things that are familiar to us as default Apache things that, again, hopefully a website administrator would have turned off. But if we can't find anything using our automated tools at this point, let's continue enumerating manually by going to the website itself. Opening up Firefox, http://10.10.10.75, and what we see is hello world. So even though we discovered all of the default Apache things turned on, the default Apache index.html does not exist. It's been replaced with some sort of hello world index.html. So from here, we'll click View Page Source. And while there's not really a whole lot in here, what we do see is a comment left by a developer saying that nothing interesting here. Obviously, this is a contrived example. Developers typically don't leave such obvious comments in the code saying that there's nothing interesting at Nibblelog, just continue on and don't look at the man behind the curtain. But developers do frequently leave comments in code that indicate the presence of things that an attacker wouldn't normally know about. So gobuster didn't find Nibblelog directory because Nibblelog is not one of the standard or more common directory names that would be present in the word list that we chose. Perhaps it would be in a larger or more highly targeted word list, so it's not that an automated tool couldn't have found this, but obviously it's not common enough to be in the word list that we chose. In either case, we'll just manually navigate to that directory, and what we can see is a website. Could be a blog of some kind. And back down in the lower right corner, it says it's powered by Nibblelog. So Nibblelog may be some sort of blogging platform. Certainly, we will continue to manually enumerate this site, but another common theme with enumeration, as we discussed earlier in the course, is that once an attacker finds something new, they will typically circle back through all of the steps of enumeration using the new information that they've discovered. And so in this case, perhaps an attacker will rerun gobuster, but not from the root directory. Maybe they'll try to run this from Nibblelog to see what comes up. And in this case, we can see that gobuster found quite a bit more than it found the first time. It did find an admin directory, it found a PHP file, it found a content directory, it found languages, as well as a README. So these are all items that we would want to begin enumerating as an attacker. Perhaps the first thing I would want to do is to go and look at the content directory. And here again, we can see that Apache has been configured to allow the contents of all directories to be openly viewed, something that a detail-oriented website administrator would never allow. Certainly, we could continue to use gobuster to help us brute force directories all across the site, but we are going to manually spend time enumerating some of the files that we see here. Private seems like a particularly sensitive directory that an attacker would be interested in. And from here, we might look at the variety of XML files that exist. Users.xml seems like it would be relevant to the kind of information that an attacker might want. And looking inside the XML code, we can certainly see there's a username of admin, and that perhaps there's an IP address that has been blacklisted. So there's some sort of blacklisting functionality involved in Nibblelog. We're not sure what that is at the moment, but something generally to be aware of. Another piece to our puzzle. Certainly an attacker will continue to enumerate all of the files that are contained within the open directories like private. They're going to dig through all of the public files, things like pages, posts, or perhaps uploads. And they're going to continue to look at the web page itself. Coming back to Nibblelog, looking at the raw source code. We can see here is another directory called themes that we hadn't seen before. There's some sort of admin directory that gobuster already indicated exists. And continuing to scroll down through the bottom of the page, we can see a bit of JavaScript that doesn't appear to be all that interesting. Again, jQuery just modifying the DOM at runtime. The most interesting thing for us to do will likely be to go check out the admin.php file that was indicated in the gobuster search results over here on the left. Viewing the source code for this page doesn't indicate a whole lot interesting to an attacker. Again, we can see we're using some CSS coming from different templates. There is some sort of JavaScript file coming out of a PHP file, which does catch my attention as a developer, knowing that JavaScript being hosted in a PHP file typically isn't something I see every day. So I might want to come look at this, where we can see it's giving us an HTML root path, an admin path, an AJAX path. It's not the easiest thing for us to read, but you get the idea. The attacker's going to be looking very closely at all the files that they can get their hands on. Things like a max file size could potentially be very interesting to us as well. Without a whole lot of other useful information found at this point, let's go back to one of the puzzle pieces that we noticed a short while ago, and that we did find a username, which I believe was admin at the time. And we can try to log in, or we get incorrect username or password. Potentially we could try to abuse the forgot password link if there was a way to reset the password and take over the account of the admin. But again, in the interest of time, what I'm going to point out is that admin is the correct username, and we would simply need to figure out the password for admin to gain unauthorized access to this web application. That sounds really simple, and to an attacker it generally is, because like gobuster, there are many brute forcing tools that exist specifically for passwords and credential stuffing attacks. Built into Parrot OS, as well as Kali Linux, is a common password list frequently used in credential stuffing attacks, known as RockU. And that can be found at user share word lists rocku.txt. And for the sake of example, I'm going to grep the word nibble just to see what comes out, since we're using the nibble blog. And we can see that there are a variety of passwords that involve the word nibble, highlighted here in red. Because password brute forcing tools can sometimes be confusing to configure, skip straight to the point, which is that the password for admin does exist in rocku.txt. Password being Nibbles. Which we can see right here at the top of our list. Hitting login, we can now see that we've been properly authenticated into the Nibble blog dashboard. From here, an attacker will certainly continue enumerating, and there are all sorts of things that an administrator might be able to do on a website, ranging from attacks as simple as defacing a website to perhaps something more nefarious like gaining control of the file system. In the interest of time, we'll skip ahead to the plugins folder, where we can see the ability to manage and configure all of the plugins that are installed on this version of Nibbleblock. What we might eventually find going into the My Image plugin would be the ability to upload files directly to the web server. The website won't prevent us from looking at file types that might normally be excluded from file uploads in other applications. Things like a shell script, or potentially a PHP file of some kind. What we might choose to do then is to create a PHP file with some malicious code just to see what we can do. So let's create a directory. We'll call this Nibbles. We'll enter that, and we'll touch an exploit.php file. Inside of our exploit, potentially we start writing some PHP code that looks like this, where we want to execute some sort of system command. Maybe that's going to take in a query string or a post parameter of some kind. And I think I need a semicolon there, and the follow as well. That could allow us to do remote code execution on the server if this file actually does what we think it might do. So let's save that, and we'll come back to here, and we'll upload exploit.php, and we'll hit save. And while we do see some warnings here at the top of the page, it does appear that it did allow us to upload that file. So the question becomes, where did it upload that file? And again, we may come back to the content, and we might look at maybe it wasn't public, maybe it was the private folder. For plugins, and then there was my image, and while I don't see the exploit.php, it does make me wonder if image.php is the thing that we actually wanted to look for. Maybe the application renamed it on our behalf. So from here, maybe I say a query string parameter for command, maybe give it who am I, and that does not appear to have given us what we wanted. As it turns out, I misspelled the word request in my PHP script. So we can save that, and we can come back to the admin page. And we can come back to my image, re-upload our exploits, save those changes. And now we can come back to our image.php, type in who am I, and we can see it has output Nibbler as the user running this process on the server. You might try other commands like cat etc password, and we can see we now have complete remote code execution on the server, and we can find users, namely like MySQL. We already identified Nibbler. Looks like Nibbler may be the only legitimate user on this box. So to wrap up this lesson, there were several problems that we identified with Nibbles. First and foremost, there was open directory enumeration, which was not turned off on the Apache server. Certainly there is vulnerable third-party code running on the Nibble blog. There was no brute force prevention of the login, even though we didn't demonstrate using the brute forcing tool to use RockU as our word list. It was clear that the password did exist in that file, and we would eventually have brute forced it had we not skipped that for the sake of brevity. And last but not least, there was no sanitization for the PHP files being uploaded. the ability to upload a malicious PHP file from the website allowed us to pivot from the admin user of the website itself to a legitimate user who could potentially SSH to the machine, thereby taking control of the entire web server, not just the website. Hopefully this example did a good job of demonstrating how we can find individual puzzle pieces to string together a more complex series of steps, enabling us to pivot from a generic user of the website to the administrator of that website, and then to a legitimate user capable of SSH access to the server itself. Are you paranoid about web application security yet? Let's dive into yet another example here on Hack the Box to see what else we can learn.